Okay, it looks like we're live. Let's see. Okay. Yep, here we go. All right, guys, let me know how the audio sounds. I'm going to post the link to this stream in Discord, and then we will get started. Okay. Hey, all right, so for those of you who are in the Dev School Discord, you probably saw my message last Saturday saying that I wanted to work on refactoring this system for following the splines in between streams, and well, I'll admit, I got distracted and did not get around to that. Well, aside from that, I spent more time working on the project for the current series that I am still trying to wrap up. But I got distracted from working on this in between streams by trying to write a byte pair encoding tokenizer for Llama 3 inside of Unreal Engine from scratch. So we're still at the same point, pretty much that we left off from, I think. No, I think I have worked on this some from the last stream. But where we are at is that after getting the turn spinning logic worked out, I tested it out, and it didn't work that great in Mojang. The animations didn't really know what foot to plant while spinning around, and that's because the spin started at the point of the turn and not before. And what I need to do is make the spin the halfway point along the turn, and I was not anticipating that when I made this. And this is still very much in a prototype phase. So I think what might be the best plan for this stream is to just rewrite it from scratch. And I think I can do that relatively quickly, and I'll have a much better idea of what I want out of this system that's going to be making the characters follow the splines this time around. And I'm hoping that by the end of the stream today, this system is finally done, and I can set it off to the side and just get the animations generated and move on to the motion matching stuff, because to respond to chat here, I definitely want to make motion matching tutorials. I'm probably not going to go super deep because I just don't know the best approaches yet. I've done some experimentation. I'm doing experimentation with it now in these streams. I'm kind of waiting for the sample project that Epic is making before I try to really go in depth on tutorials, because from what I've heard, it is going to be nuts. Caleb Longmire, the person who made the advanced locomotion system, is pretty heavily involved in it. So it's kind of going to be, now what's coming up next isn't anything I've heard specifically, but I'm going to say that it's probably going to be very similar to what the advanced locomotion system version 4 was for just animation systems in Unreal Engine 4. It's going to kind of set the standard moving forward with motion matching, chooser, and all the new tech in Unreal Engine 5.4 and beyond. So until I'm able to get my hands on that, until that releases, I'm not going to go super in-depth, but I do want to cover things at least a surface level. Here's how you get started. But past that surface level, I really have no idea what the best techniques are. And it takes a lot of experimentation. So I'm probably going to rely on that project from Epic and do something similar to what I did for the Lyra Locomotion System Explained series, but at a much better quality, because I think I can produce those sorts of videos at a much higher quality now and keep the runtime down and make everything more efficient than I did back when I was trying to make those videos. So I think what I'm going to do here is I have this Motion Spline AI controller class, and I'm just going to make a new AI controller class and really start from scratch here and see if I can just power through this on stream with you all and walk through the logic as I lay it out. So the key here is that we want to drive all the motion of our characters with add movement input. And that way, the movement model that we get for these trajectories that we put into Mojang to get animations out matches the Unreal Engine movement model. So as far as just locational movement goes, every bit of logic here should be working towards building the appropriate world direction vector to keep the character as closely aligned with a spline as possible, while respecting the movement of the character, in that we don't want to force the character to the spine so that it makes impossible turns or moves at speeds or has acceleration values or does anything that wouldn't happen if we were just receiving normal movement input. And aside from adding movement input, we want to be able to configure the rotation. There's generally two main rotation approaches when it comes to locomotion. There's an approach where the character faces the direction of movement and an approach where the character faces the camera, which is just strafing. However, in certain situations, during certain pivots, the more efficient movement becomes a spin, where the character doesn't take the shortest rotation to a target rotation and instead takes the longest rotation and does a spin. And that kind of comes down to which foot is about to touch the ground relative to the orientation of the character, and we can get back-facing spin pivots out of Mojang. But my previous approach did not provide the trajectory and the rotation in the way that Mojang expects or works best with. So that is partially why I want to revise the system. The other reason is that the old spline following system is a mess. I kind of just developed it linearly without much of a plan through a lot of trial and error, and it is a minor miracle that it works. I iterate the motion spline point index twice, and it should only be iterated once. And I don't even remember the conditions here. And so it's difficult to work with and expand in any sort of efficient manner. And I want to make a tutorial on this so that you guys can get characters following splines and have your own systems to input, to use to generate locomotion animations from Mojang. And I also want to be able to provide the project files through Patreon. So I need to get this into an actually usable state as far as it being a tool goes, so that I can make a tutorial, show you guys how it's built, explain everything, and move on with this motion matched locomotion system. So what we need now is a plan, something I did not have when I approached this for the first time. And I do have the microphone positioned a bit differently today, so let me know how that audio sounds. I don't want it to pick up too much or be too close, but it is a little bit closer. I'm trying to optimize for the actual type of microphone that this is. So if there are any audio issues, let me know, guys. Okay, so first off, we need to get data. So what I like to do when I'm planning blueprints out like this is to use a sequence node and kind of separate out the steps. I can just put a re. I meant to reroute node in, but I don't have context sensitivity turned on. Put our reroute node in and comment it. And then once I have everything commented in the entire flow of the system, I'll start filling it in section by section. So get data is just what I'm going to say here. And I have structs in place to deliver data that I can use from this system, but I don't want to just default into using the data in the current format that I have, because what I want to do is, if we look at a spline here, let me just grab one. This is a spline that is generated as a turn in a construction script based off of a drop-down enumerator, and I have settings here for the different types of splines that can be generated for the character to follow as we record the motion. And let's see here. So here I can set a section length. This turn distance should be renamed. It's more of like a segment length. And then the turn angle, because it's difficult to find the right point, just moving points around to get turns at specific angles for certain increments. So I just made a quick procedural generator. But what was my point here? Oh yeah, so we look at the spline, and this is an example of a spline with really just one turn, but I don't want to restrict the system to that. If someone wants to go in and manually make a full-on, like Ubisoft Locomotion long-form dance card style trajectory spline, similar to what Ubisoft showed in their initial GDC talks about motion matching, I want them to be able to select a point on the spline and tell the system if the character should do a spin at this turn point. So what we're going to need to do is make a modification to the motion spline base class. And now I'm trying to remember, what is this here? I don't know. Huh. But we do have this spline movement profile struct. We can set the max walk speed, the acceleration, the deceleration, ground friction, like character movement values for the spline. So what I want to do is maybe not add this to this direct, but instead, let's create a map. And we're going to map booleans to integers. I'll just name this spin turn map. And I'll expose this variable. So now we have our tag map, and I can add an element to it. Or no, not our tag map. I don't know what that is doing there. That's not what I made. That's something else. We have our spline turn map. So here I can add the index. In this case, it would be 1 for this turn here, and I would set it to this boolean to true. So at spline point 1, we do a spin. And this is not an angle you'd want to do a spin at, like at 180 or like 135-ish. Maybe 90 is when it might become beneficial to do a spin pivot. But anything less than 90 degrees, and I don't think we'd want to do spins ever, or I'd want the motion matching to pick a spin animation ever. So instead, we'll just do spins for this hemisphere and then prune that and figure out where we actually want that coverage later on. The other thing we need this new system to support that the old one doesn't, I don't think that's a word, that the old one doesn't, is explicitly stating the turn direction. because if we do a 180-degree pivot, we want to be able to say whether or not we turn clockwise or counterclockwise. So I think instead of making this a spin boolean, I'm going to name this turn direction. I'll say turn direction map. And so I'll just say that true or false is going to either be counterclockwise or clockwise. And so if a point is in this map, it means we're overriding the turn direction. And if it is not in the map, then we just use the default movement of the character. So this gets complicated in that we want to be able to start a turn so that the point along the spline is at the halfway point during the turn when we spin. So, just really trying to think this through now. Because there's a lot of different behavior that we might want when following a spline. I think the best approach might be to like really try and do this more functionally. Have different turn behaviors, split off into functions, and then we query the current segment we're on and find the appropriate function for that segment based on the settings. So instead of trying to work it all into some monolithic spline follow function, we kind of split things up. So the actual movement of following the spline, that's going to be pretty standard. But the actual logic for how we rotate, that's going to be a bit different. So yeah, subdividing the spline could be an option. Like if we follow different splines or have different splines in sequence, we could have settings for each spline separately. And that could be an approach. It's something I considered in the past. We might end up doing something like that. But for now, I'm going to try and just assign data to spline points. So what we can do is we can get our location along the spline and keep track of that. So that isn't difficult. And from that, we can always know what our next spline point is and adjust our behavior accordingly. So I think we're going to want to track some data constantly. We're going to want to track a previous spline point and an upcoming spline point. And we'll want to know if we're going to be overriding the turn. We'll probably want to classify spins. Really, if we're overriding it, it's because we're spinning. So okay, I think we're going to go back. And maybe I'm just confusing myself here. But I think we're going to make this map just to spins and just focus on spins. Otherwise, we're just turning normally. So instead of override next turn, we'll name this spin. next turn. And we'll probably want a function. And this is going to be, I'll just name it handle spin. And we'll probably want to take in our next spline point. A turn angle, which will be a float. And because the halfway point of our turn should be at the actual spline point itself, we'll want a turn or a spin. I'm going to call this spin distance. And this is going to be the distance from that point that we start our spin at. And given these values, we should be able to calculate a rotation or a yaw output for the current frame. And what we will also want to take in, I think, is our current yaw. Maybe, but what we also want to do is our current distance. And this is going to be our distance from the upcoming point. So now let's calculate this inside of the function. Okay, so I'm switching over to address chat here, everyone. And so I'm not exactly certain what your question is asking specifically. I've been looking at motion matching in 5.4. I've been working with it in a limited capacity. But to address the project that'll be coming out in June, I want to do a much deeper dive into that project as soon as it comes out, pick it apart, learn everything I can, and then share what I learn with you guys. And that is my plan for that. Okay, so we're taking in a current distance. Is that right? Our next spline point. That's all we need. That is all we need. And we're going to handle our spin here. And for the time being, we're going to treat this as a black box and assume that all this logic is implemented properly for the sake of trying to figure out our logic flow here. So we know that if our next turn is a spin, we should be handling our turn using our handle spin function. And I think instead of outputting a yaw, we're going to output a yaw, and this is going to be a target yaw. Because this handle spin might output a yaw value completely different than what we previously had. Ideally, it shouldn't. But I want to be able to account for instances where this here outputs something different than what we had previously. And so what I want to do is perhaps always be interpolating the rotation. So I'm going to have another function, and it's going to be handle yaw. We're going to input a target yaw, and we're going to have input a current yaw. And we're not going to output anything. We're actually going to set the yaw inside of this. This will be like the termination point. And however we decide to implement interpolation, we'll do it here. And we'll have movement settings to take into account, but I can configure those inputs later. So we're going to have something that looks a lot like this. And I haven't really thought much about strafe spins. We might want those eventually. I've only considered forward-facing movement so far, but I think that's all right. We'll just focus on forward-facing for this current iteration of this system. Because I'm splitting this apart into functions, it'll be a lot easier to expand and add new behavior in the future. So we're going to have a function calculate forward facing yaw, and instead of this being named handle spin, I'm going to name it calculate spin yaw. So the handle function is going to apply, and the calculate is going to calculate a desired yaw. So we know we're going to output a target yaw. Really, I almost feel like it would be best just to handle this by just letting the character movement component do as much as possible, and that might be the best way to really go about this. To rely on the character movement component until we shouldn't. So, I believe a slightly different approach might be best. We want to keep this calculate spin yaw, but instead of having this calculate forward facing yaw, our handle yaw function will take an override yaw. I don't know if that's best here, because we always want to be interpolating our yaw. We might just not want to rely on the character movement component, and I think that is what we need to do. So instead of an override yaw boolean, I think we will just manually handle our yaw and give ourselves more control. Because as long as that's relatively close to what we have in our movement model, motion matching should work fine. So we have calculates forward facing yaw. And we don't really need our next spline point. I think what we want is our current distance. Current spline distance. And that's it. Given a current spline distance, maybe we'll just take our input vector instead. The character might not always be fully in line with the spline, especially on really sharp turns. So yeah, let's take in our input. I'll say velocity direction. And this will be a pretty simple calculation, but I don't want to get too deep into implementing anything yet. So now, if the next turn is a spin, we switch to our calculate spin yaw function. And I might change this condition to say if our distance, to check our actual distance to this point, and track the spin distance. That's probably going to be the final form. So now we're going to want to track target yaw as a variable. So both of these will set target yaw. And they'll terminate into handle yaw. So already I feel like we have a much, much, much better approach for handling rotation. And I know I said let's start here and do a sequence, and that would be working forwards, and instead I think I've ended up working backwards. from our desired output towards our input. And I'm just going to keep going in that direction. So we know we want to add movement input. We need to add movement input, and that's going to require us tracking an input vector. And it's that same input vector we'll probably want to use for velocity direction, or maybe not. We might want to get our actual velocity. So we'll leave that alone for now. So now we need to calculate this input vector. That's going to be very, very important. And we'll want to track our previous spline point and our next spline point. So what we need is a character. So I'm just looking. We have get controlled pawn. And I have a motion spline character class that's configured to specifically follow these splines and pull the settings from the spline and apply that to its movement. So I'll just make this a variable. Named character ref. I'm just going to toss this on to begin play. And we're going to assume this all works properly. We might need to fix it, add more logic here, probably will. We'll need to get more data. But for now, we're working backwards. So we're going to assume that we have our character reference here. And so we need to find our input vector. And so far, there are really two ways of following splines that I devised in the previous system. One is to find the vector that points towards the next spline point. And the other is to resample the spline at small increments so that we can follow a curve more accurately. So, similar to how we handle rotation, there's two options for how we handle movement. And we don't need this open right now, or this. We have a mode where we're either going to, we're either going to resample the spline so that we can follow curves, or we're not going to. And I think it would be good to hold this data in that same map as well. So here's what we're going to do. That tag map was something I made. I don't use it and I don't remember what my thinking was for it, so I'm just going to delete it. Instead of mapping booleans and calling this spin map, I'm going to say point, I'm going to name this point settings map. And I'm going to create a new struct. I don't know if I'm going to make use of either of these two structs. I might start from scratch here and do this in a more organized manner. And I'll name this motion spline point settings. So previously, our settings were calculated or were stored for the entire spline. And now we're essentially treating each point as its own unit and giving it these settings. So should spin is a setting. We also have should stop. Now, if we're stopping, we can probably still we're not going to be spinning if we're stopping. So that we're just going to have to track and apply into our logic that if we're stopping at the next point, we can't spin. Spin is only going to be done if we're moving continuously. But if we're stopping, there should be a stop delay. I'll name this stop duration, and it'll be a float. Anything else? I don't think so. We can keep adding stuff. But now we have, and here we have a boolean, spin next turn. And we want to track this because we want to override the settings if we're going to stop. So we want local copies of these settings. So stop next turn. And instead of saying turn, I'm going to be more verbose and say spin next point. Whoops. So spin at next point. Stop at next turn. Or next point, I mean. And what I did not do in the previous implementation was categorize my variables and functions, and I want this to be the final version. This blueprint, this class, this logic is all intended to be the final implementation, can be built on, but the idea is I'm never starting from scratch. It's not throwaway code like the previous one was. So I'm going to really pay attention to organization here and try and comment all my stuff too. So we're spinning at the next point and stop at next point. So these are the spline point settings. So next spline point settings. And instead of saying settings, I'm just going to say next spline point data. And I'm going to toss our next spline point index into here. So in that same manner, we're going to have a previous spline point data. I don't know how much data we're going to track. We might just be tracking our previous spline point index. And for the character, the category is going to be just actor references. Probably like a better, cleaner name for that, but that's all right. And we're also going to want to reference to our actual motion spline. Okay, so we have the data that we are looking at and that we need right now. But we're going to need more data for the system than this, but I'm going to work backwards from what we have. So we need to get our next spline point, and we need to know what that is. For this section, I'm going to assume we do know what that is, so that I can, from our motion spline ref, I can get our map. And I never updated that to use the struct. So instead of a boolean, we're going to do spline point settings, or no, it's motion spline point settings. There we go. This is motion spline base. That's motion spline base. So I think I just need to recompile. What's the name of this variable? Point settings map. Okay. There. Now we can get our point settings map from our motion spline. And we can find. And using our next spline point index, we can find the settings. We might not also have settings. So we should have a default behavior that we default to. So let's get a branch here. And if we should stop, we're going to set stop at next point to true. And we don't want to calculate this every frame. So this is going to need to go when we increment the point, we're going to find the settings. So I'm making a note of that for myself. We're going to set that directly. We're also going to need a stop duration. Which we'll also set directly. And now we have our spin. We can't set our spin directly with should spin because we need to account for user error now. So if we should spin and should stop is not true, those are our conditions. But we should only set these values if we actually find settings set for that point. If we do not find settings set for that point, then we need to do default behavior, whatever that turns out to be, and to keep this organized. And instead of actually looking up this value, so what actually happens here is that when we set stop, we look up the point. When we set our duration, we look up the point, and we reference that map 3 times in a row. We don't need to do that. I'm going to make this a variable. I'm going to toss this in the references. We don't want to use this directly because we have some conditional logic here, at least for the spinning. So I want to have kind of a layer in between these two. But what I can do what could be better, and I just thought of this. Original next point settings and next point settings. So we're going to set our original next point settings, and I'm actually going to put this in a function. So collapse to function. I'll figure out a name momentarily. And I'm going to delete the original next point settings. And I'm going to make this a variable. There we go. All of these are going to become local variables as well. No, we're just going to hard code this, make this a bit simpler. So we're going to have an output. I'm overcomplicating things here, guys. I'm really overcomplicating things. I think it's important to have clean blueprints, but in some cases, you just want to go for efficiency. And this is, I think, definitely one of those cases. Not the most readable, but it'll do. And it's encapsulated inside a function. So now we don't need to ever think about this again now that this is here because it's inside a function. And we can, leave it a little bit messy as far as the actual node organization goes and not create a bunch of extra local variables just to have our lines uncrossed and unspaghettified. So we're not going to stop spin or have any stop duration by default. So if we don't find anything, we use the default. And what I think I'm going to do is expose this. I named the wrong one there. There we go. And we'll name this set next spline point settings. So we know we need this, in between the sequence and the beginning of this logic. And now we can delete all that and have that data stored in our struct here. So now we can access our struct, break it open, or split it, and hook up our should spin. And the spin is only going to be true if we're not stopping, so that conflict there is now resolved in our logic here. And I'm just going to connect these up, and there's probably going to need to be more that goes in between this. Specifically, we need to track where we're at along the spline, and this is going to be the most difficult part. Whoop, knocked my microphone. I apologize, everyone. This is going to be, I think, the most difficult part of this whole process here of refactoring this system. Because we're not forcing the character onto the spline. So we need some way each frame to figure out what's the closest point on the spline. There's an issue, though, is that if a spline overlaps with itself, we could accidentally skip a section if it decides that we're closer to the point of overlap that is further along the spline. So let's think here. Ideally, what we can do is we should be able to, I'm hoping, isolate a segment and find the closest point along a certain spline segment. So that would be the ideal way to go about this. And so what I need is to just look at the functions that are built into Unreal for working with splines. Oops. I meant to do a get, not a set. Okay, so this is our spline. that we're actually following. We're going to assume for this segment of logic here that where we're tracking our distance along the spline, tracking the distance of this character, that we know our previous spline and our next spline point index, that these are set properly for the current frame, and that if we need to set our next spline point index, we're going to do that after this. So something like that with a reroute where these paths can reconverge. So we're going to have a segment of logic that looks something like this. And guys, it'll be a miracle if this works the first try, but we can hope. We press play and this logic works. Okay, so motion spline, our spline path. Okay, so Bad Radish, good to have you here again. So because we're using essentially AI generated animations generated by a machine learning model, we're generating trajectories to feed into that, and you're probably aware because you've got previous streams. And so last stream, I think I worked on doing spins when turning. That didn't turn out perfect. It didn't turn out right or fully right. I was able to get the character to do a spin, but I didn't have as much control as I needed to actually get a good trajectory to input to get an actual good spin animation out. And so I'm rebuilding our component to have the character follow a spline from scratch. And I'm trying to make it much better, more modular, and more easily extendable. The previous one was held together. Like, I'm surprised that it works. I'm supposed to only increment this once a frame. It could possibly get incremented twice a frame. I'm lucky that this held together as good as it did. It's a complete unorganized, unplanned mess and terrible to work with. So I'm making one better. It's going to be actually worth making a tutorial video on or sharing as a project file on Patreon. So I'll be doing both of those things. Full tutorial and project file available on Patreon along with the motion match system once that is ready. Probably a bit before I actually end up making the final tutorials. I said I'd refactor in Discord between streams, but I got distracted by a side project that I'll eventually make a video on as well of coding a tokenizer, a byte pair encoding tokenizer from scratch in C++ for the Llama 3 large language model, all inside of Unreal Engine. I'm not a programmer. I'm kind of sort of becoming one the more I work on this kind of stuff for fun of all things. But yeah, that's been distracting. I am really learning how to read out of JSON files or however that's properly pronounced. I probably did that wrong. JSON. I don't know. In Unreal. It has some good tools for that. And I'll probably make a dedicated video. Yeah, I'm not a... Yeah. Maybe I'm a little bit more of a programmer than I give myself credit for. But my code might look horrendous to an actual programmer. Right now, I just read from the JSON at runtime or JSON from runtime, and it slows the... It like takes way too many milliseconds. But my final plan is not to read it at runtime. It's while I tokenize, it's to I read it when I set up a tokenizer object, but yeah, that's not my final plan. So hopefully my code can be efficient by the time I'm done with that. Anyway, back to what we're actually working on during the stream. Maybe I'll stream some of that project and my work on it when I'm a little bit further along. Okay, so spline path. We've been at this point for at least 5 minutes now as I've rambled. I apologize. So let me think here. Can we get... We can find our points closest to a location. Can we get... So... Yep, so am I, Bad Radish. So am I. Let's think. I can sample the entire spline. I would much rather just sample the section. Okay, here's a thought. Why? What's the name of this darn function though? Because I might be missing something here. Let me look at my old one. How did I do this? Get distance along spline at spline point. Where am I actually getting the spline point though? I don't even check if I should increment the point first or no. I have to get the distance, I guess, but that's not even what I'm... Oh gosh, I really don't know what the heck I was thinking when I made this. Where do I sample the spline? What the heck? What the heck was I thinking? Oh yeah, ooh yeah, that's not a good way to do it. That's really prone to error, my goodness. Okay, that's bad. Very bad. Okay, so it's I'll just say get transform at distance along spline, at spline input key, at spline point, at time. We can get the distance along spline at location, at closest point of the provided input location. Like this would be awesome. We could pass in our actor location, get our distance along the spline, and use that to get all the other data from the spline by passing in the distance to its other get functions. The issue being when the spline intersects. And so here comes in my idea. We subdivide the spline, which was suggested. I'm not sure if this was the context or the thinking behind the suggestion earlier during the stream, but gosh. Yeah. Okay, guys, like if this is a bad idea and there's a better way to do this, tell me. For those of you who've worked with splines in Unreal more than I have, but I'm going to brute force segment this spline. All right, let's go. At runtime, we are going to split this spline up. Okay, I can get the number of segments. I'm just going to put in the word segment. That's all we can do. Like Unreal tracks the spline segments, but I can't query those spline segments separately in Blueprint at least, and that's what sucks here. Okay, so, construct object from, gosh. I have to transfer all the data over. I would really rather not create like a spline for each segment. That just seems like complete overkill. I have to be missing a simpler way of sampling the spline. What I want to do is sample in like an absolute manner. Previously, I was tracking the distance the character travels in between frames and incrementing the tracked distance along the spline. But if the character doesn't follow the spline perfectly, those two will get out of sync as time goes on. So every frame, I don't want to like make any assumptions. I want to just get our distance along the spline or the closest spline point or the closest location along the spline. And I just want to do it without referencing any previously known values aside from the character location and our current spline point or our previous spline point and our next spline point index. So, gosh, how do we do this? If I could just get distance along spline or closest spline point on segment, this would be so much easier. I can convert a spline segment to a polyline. Don't think that's useful. Why can't I do more spline segments? Maybe I'm just using the wrong keywords. What is a polyline? So I want this to be robust. I had a bad implementation that was good enough for prototyping previously, but this needs to be foolproof. Okay. We're going to have to do it the long way. Oh, gosh, this sucks. Because we're tracking stuff on a point-by-point basis. So we can't just split off each segment. Or I guess we can. We can split each segment and we can track our current segment. And we can track the primary spline. So we're not deleting the primary spline, but we are creating a bunch of extra splines. Darn. Hmm. We could subdivide the spline at a fixed increment and only move to the next spline point. And we would just like track a subdivision level. And so not treat following a curve separately. But that would change the point index. Darn. Okay, so we don't want to subdivide. if we don't need to really subdivide. But I could resample so I could get our current spline point. I can know what our current spline segment is, our current distance as we start on the spline. And if I resample the spline and construct an array of transform values mapped to distances along the spline, I can figure out which one of those from that array is closest to the actor location and treat them as virtual spline points for the current segment of the spline that we are on. I think that's going to be, yeah, it would essentially be like a virtualized spline, if I'm using that terminology correctly. All right. That's going to be it. That's what we're going for, guys. So we need a resample distance or a resample increment value that's going to be owned by the spline itself. So here's where this is where we have get our actual spline settings back. So we have this old struct, this motion spline follow settings. I don't want to break anything, so I'm just going to rename this old motion spline follow settings and create a new struct. And just name it motion spline settings float, and I'll name this resample step, and the default is going to be 10 units. Or I guess I can't. Yeah, I can't set defaults in structs, can I? That's fine, because I can set that in our motion spline base. So let's do motion spline settings, make it a single. Compile. Our resample step is 10. Okay, so now from our motion spline, we can get our motion spline settings. And from this, we can get our resample step. So we're going to look at our current point, or a previous point, which is always going to start at 0. So this will always be correct. And we're going to get the distance along our spline at this point. And I think what we're going to do is we're going to just do this once and process this and pre-process the spline. And I think we might end up moving this into the motion spline itself and doing this at begin play, and then saving this, exposing this to the motion spline AI controller. Not in the construction script though, in the event graph. Okay. So let's get a for loop. And we're going to get the number of spline segments. Or I might not bother with its built-in segments. I might just infer segments later on. I think I'm going to do that. I'm just going to start from the get number of spline points. Yeah, we're going to need to track segments, but I'm just more comfortable thinking through it all myself, I think. Unfortunately. So, okay. We're getting our number of spline points. What do we do now? What do we do now? We have our for loop. We're iterating over the spline points. What do we need to know? We need to get a segment. Okay, so we are going to track our segments. I'm just going to have to deal with that. We also need to track our current segment, which is fine. We need to know what point we're at. So given a spline segment, given an integer, we need to find our points, because we are iterating on points. We're incrementing at distances along the spline. What is a key? I don't know. What I want to start from this. So we know a segment goes from one point to the next. So I'm going to need to do a lot of debug drawing to make sure this works, guys. But I don't want to track this on I want to track points, but I'm more worried about sampling at distances. But then, oh gosh, yeah, this might not be the way to go, because if that distance doesn't line up, the distance step increment doesn't line up with the turn, then we are in trouble. Okay, so back into our event graph. Let's get our spline path. Spawn actor from class. We'll get the class, which is just normal spline path, but or add component by class. Or maybe we step forwards and backwards each frame from the ends of the spline towards the middle. And if the distance threshold is off, that's fine if it's a little bit off. But I would rather just keep a reference to a spline that's just the current segment. Okay, so we're going to add a spline component. I'll do it as spawn actor from class, and we're going to get we're going to add a component to this. Oh, this is so weird and just messy code. I just feel like I'm breaking so many rules. I don't know exactly which rules, guys, but I'm breaking them. Okay, we're going to spawn actor from class, and we're going to make a new actor. It's going to be virtual motion spline segment. And it is going to hold a spline. I'll name it spline segment. So we're going to spawn actor from class, and it's going to be virtual motion spline segment. And we're going to get our spline segment, and we're going to add spline point. Can we set the interpolation though? Oh darn, if we can't set the interpolation, then we might as well not be doing this at all. The whole point was to create a spline with the same interpolation type. That matches exactly. Okay, yep, nope. We can't take this approach. It should not be this hard to get the location, the closest location along a spline within a spline segment. And then you just don't overlap segments. But what if a segment does overlap with itself? That's possible, isn't it? Darn. Huh. If you're doing like a certain type of interpolation, no, it's not going to overlap with itself. It's not going to do that. We still want to get it like on the main spline, and I'm just not comfortable with creating a secondary spline. And there could just, that introduces way too much complication. So one idea I had is just brute force it and call the function on the spline over and over again until it returns a distance that matches it's within the spline segment we're on. But that's just like terrible. Because theoretically, you can, infinitely call that. Unreal's not going to let me do it because you have a potential infinite loop of never, the closest point never being the spline segment you're on and being the spline segment that overlaps with it on that frame. That practically that you wouldn't run into that. It would give you the right one, probably like a 50-50 chance for the frame. But still, we'd be creating a potential infinite loop. So even if I really wanted to, Unreal would not let me compile that logic. I did not think I'd get so stumped on stream figuring this out, guys. I apologize. But I am stumped. I just wish Unreal would have a... I'm just going to Google this. Maybe someone has run into the same issue as me. Unreal Engine. Find closest spline transform on segment. So I'm just looking this up on my second monitor, everyone. And we could just make it a rule that you never overlap splines, but there's the closest spline point to a location. That could get messy. If the spline it's too close. Yeah, we need to get distance along spline at location. Like I've run into issues doing it that way because yeah, it gets so difficult when you're not actually constraining yourself to the spline and hard coding the location update. If you're just trying to find the closest point on the spline every frame to an actor without skipping segments of the spline accidentally. It's difficult. I wonder what the algorithms look like in like you have the robotics where you have sensors looking at lines, looking for contrast, and there's like line following algorithms out there, I'm sure. That would be, more complex. So there's a lot of data we can get and we can bake in and have baked into the spline. If we know the unit, the vector from the previous spline point to the character and the character to the next spline point and the distance, I feel like there should be a way to use that data, to really use that data to figure this out. It's going to have to do with that, I think. We have the vectors. We can track the character relative to those spline points. Like, gosh, if there was just no interpolation, we could treat each spline segment like a line section, and the math would be so darn easy to figure out the closest point along the line segment, but the moment it starts to curve. And if there was just a way to sample an Unreal Engine, the spline segment, without sampling the entire spline. Continuing just to search the internet for examples. Looking at the actual C++ documentation. What is a spline input key in Unreal? I don't think that's going to be helpful. Okay, guys, we're back to subdividing the spline. That's really the only way, and actually making multiple splines. So I'm back in our motion spline base at runtime. We're going to take our spline path, and we're going to iterate through it. I wonder if there's functionality for this. Split. No, maybe. Can I? Okay, so okay, so let's get our. There we go. What can we set on a spline? Location, rotation, scale. What's point type? I think just setting the tangents. Yeah, set tangents at spline point. And get tangent at spline point. Or so we're going to get arrive tangent at spline point and get leave tangent at spline point. And so let's get number of spline segments. Get a for loop. This is starting to come together in my head. So we iterate through the spline segments. For each spline segment, we're going to add a spline component. And we're going to add this to an array. I'll name it spline segments. Okay, and there's been some chat, so I'm going to turn back over. I was in another tab and read through that and catch up, everyone. So just a moment. Yeah, I want to curve the character perfectly so it can follow spiral splines and that sort of stuff. I'm not sure what is the ALS plugin. I mean, I know that in the context of like advanced locomotion system. It sounds familiar, but is a plugin something different? Or if you're talking about like the advanced locomotion system, it's pretty great, but there's a lot of new functionality in Unreal. Caleb Longmire, the person who created it, the advanced locomotion system, is pretty involved in the upcoming motion matching, character animation, locomotion sample project that'll be coming out next month. So that I think will probably replace the advanced locomotion system as the most up to date like reference for how to make great locomotion systems in the engine. So we're adding a spline point here. So for each one of these, we're adding a spline point. And let's make this a map. And this is going to be an integer mapped to can we not do a spline path? Or it's not spline, it's just not spline path, it's just a spline component object reference. So now we're going to add an item to our map that's going to correspond with our current index. This will need to be collapsed and we'll need to make this a local variable. So let's do that now. Okay, so we're going to set our spline segment index. We're going to add the point we're creating to this map, or the segment we're creating. So we've added the spline component, but we need to set the points. So we have our segments index. And I think this can match our first point. So let's get location at spline point. I'm going to set that there. And now I need to really duplicate this. I don't want all these lines going everywhere. going to set this one. I'm going to have another local variable. Current segment. Do this whole thing again, but it's going to be spline segment index +1. But that doesn't account for the last segment. So, but this is point index, so that'll be fine. That will be fine, and that should work out. Okay, so let's test this. I'll name it it's not really subdivide, it's more like split spline or create segment splines. Okay, where are our errors at? Oh, I did not provide a target for these. So we need our current spline, the one that we are segmenting. I'm not sure if this is all the data we need to copy over. Well, let's test that now. I'm gonna save everything first in case I do something that crashes the entire engine. And we'll use this curve as reference. So I'm gonna select it, because if I do simulate, while it's selected, it's not gonna show up. Yeah, we only have one spline. Oh, okay. Let's see what's happening here. Stuff's happening, guys. Almost, but like we're getting somewhere with this. We're getting somewhere. That's all the spiral. I have a bunch of extra spline paths, but they're all wrong. Let's see. Let's figure out what's going on here. So I might be wrong about the way I'm mapping spline segments to points. So segment 0 is going to start at point 0 and end at point 1. Segment 1 is going to start at point 1 and end at point 2. So it should all work, I'd think. Oh, we're only adding 1 point. We need to add 2 points. Duh. How does... Okay, that's still bad. What am I missing? So let's not set tangents yet. Let's just set the points. And then it should be a linear interpolation and be easier to see what's happening here. Oh, I know what's happening. Maybe, maybe not. So for each of these, we set our segment point index and we add a new spline and we set its location. What just happens if we do that in world space instead? I don't think it would make a difference because we're getting that location in world space. No. If any of you guys see something here with the logic that's standing out to you, let me know. I'm probably missing something very obvious here. So we add a spline component. We take that component and we set it. I mean, not we set it, we add 2 spline points to it. We get the location at the spline point of the original spline path for the current point, our first point, and our... Okay, let's do this for every point instead. We're getting our number of spline points minus 1 or 2, and we should have done spline segments minus 1. So let's just see if that fixes it. Because we're iterating 1 time too many, and that could have created the issue. Still an issue. Okay. Pretty much the same result, I think. I'm going to grab this and move it over and untangle it from everything else. Just to get a clearer idea. Okay, that's weird. Where does that lead? Where does that lead? What happens if I take manual attachment? I don't know what that does. That seems better. We're still off, way off. Like some of the points are all going to the starting point. Let's just look at last index 0. Let's just see what the first segment looks like. It's going from... What the heck is happening here? Okay, so we can see it. It's like starting at... Whoa, huh. It's going from here to here and has like a really weird tangent. We'll just ignore the character really spinning around and messing himself up there. So this should start at 0. So we're just going to debug this one by one until we get it to work. but it's starting at point number 1 and going to point number 2. We're not setting tangents, but let's go ahead and try that. Oh. Huh. So arrive and leave. Those are lined up properly. Huh. It's not going to change where the points are at, though. So why is it putting the points in the wrong spot? That's the real question. Unless like the spline doesn't start at like increment 0, which would be really, really weird. It should. Oh. What is going on here? I thought this would be much simpler. Just make a spline with 2 points with positions that match the points of the segment that we're working from. In this case, we're looking at segment 0. A relative transform. Maybe that should just be zeroed out, and the transform should come from this here, because we're adding a point. Let's make sure we don't start with any points. Okay, there we go. There's a spline point added. Okay. It started with like a single spline point. That was our issue. Or some number of spline points. I don't know the exact number. I'm guessing a single one. What happens when we add the tangents now? And that was offsetting everything by like 1. Okay, it matches. The first one matches. Okay. Okay. I think we have it, guys. I think we have it. Let's do 3 and 4. We're just gonna hard code where we're starting and look for the 1. Okay, tangents are not there. That's fine. There just might be other data. I don't know what data makes up a spline, what's important. I'm not haven't used lots of splines. I'm gonna organize this momentarily. I just want to see, did that work? Nope. Nope. We're so close yet so far. I wonder if rotation needs to... I don't know. That's really weird. Like, I'm not even seeing any difference. Maybe a tangent isn't what I'm thinking of. Well, go ahead and hook up the entire loop here. And there is an update spline setting here, but I wonder if I manually call update spline at the end. Maybe that'll do something. Nope. Okay. Darn, I thought we had it there for a moment. Gosh. I wonder if it's because there's only 2 points. If I need another for loop. Because when there are 3 points, it was doing weird stuff and like applying the tangent and that was affecting things, and now it's not doing anything at all. So now we just do everything once. And we add our current index. So I'm going to make sure we haven't broken anything, or that I haven't broken anything. No, okay, still functions. So now hmm. Bypass the first for loop again, guys. And just look and see what happens when I do the first 3 points as a spline. See, so now it's curving itself. But it's not curving itself properly. Like it, what the heck is happening here? Just gonna manually put a weird number in and see if it has any effect. Oh, looks like no effect. So it's like this tangent isn't even. Huh. Only other thing we could do is like add extra points into each of these splines, and I think I'm just gonna do that, guys. It's the easy. Like I know that this will work. That'll work. So let's just do that. What sucks is that the actual distance between points might not always be uniform, which I don't like. But I can rework my spiral function. So, no, gosh, do I know? I don't know if that can work though. It can, but I just I'd really rather just get the spline to line up. I would really, really rather just get it to line up. I really thought the arrive and leave tangents would be it. But maybe if the spline is being... That spline type probably does really matter. Maybe that needs to be set before we set the tangent, or the tangent won't apply if it's just linear. So let's set it to curve. Hard code it. Yeah. Grab this. Might as well just... Okay. Yep. Okay, come on. What's current spline? It's probably just trying to be efficient, and it's not updating the spline if the tangent doesn't matter. Darn, nope. Well, I don't know. What is the actual point type here? Yeah, so that's what the tangent does, which is what I thought. That's good. Type curve. So in this, we set the type. We'll try curve custom tangent. Why? Why won't this work? This is really stumping me, guys. Oh. We're calculating this wrong. We're calculating the point index wrong. Or I'm calculating the point index wrong. I really should have seen this sooner. I'm passing in like the actual spline points from the original to the current one, and the current one is always going to be 0 and 1. It's always going to be subpoint index. I get the value from the previous with that. Ah, how did I not see that? Of course. Darn, I should have seen that so much sooner. So much sooner. Watch, it's going to work now. Yep. Yep. It lines up perfectly. I am so glad I didn't miss that. I can't believe it took me so long, but I'm glad I saw that, guys. Okay, this is done. We now resample the spline, and we fill in the map of spline segments. Awesome, awesome, awesome. We can finally move back to our controller. So now we need, what we're working on is getting our distance along the spline. So we need to track our current spline. We need to derive our current spline segment from our current spline point index, which should just be our previous spline point index. So let's plug that in. Let's get our motion spline reference, and let's get map. And I can't remember exactly what I named that. Don't need the virtual motion spline segment class. That can be deleted. I named this spline segments. Okay. So get spline segments. Nope, not what I'm trying to get. Unreal. Okay. And now we can find closest point. Okay. So this is returning a spline component. Get distance. Oh, I don't have context sensitivity turned on. What? Why is it not? There we go. get distance along spline at location. Our in location is going to be our actor location. Get actor location. There we go. Coordinate space is going to be world or global. And now, this is just the distance along the segment. So, this needs to be, we need a distance offset. Or no, I think, let's just not use distance. Let's get location at, at spline input key, at spline point, at time. No. What about transform? Find transform closest to world location. There we go. So now this spline matches the original perfectly, so we can just use it. So now that we have our transform, we can get the distance along our current spline. So we can get our actual reference to our actual spline. We can get our distance. Okay, guys, that's the hardest part of this done. We have our distance along our main spline for the current frame, and we can update that each frame. So given our current spline distance, we can do a lot now. A heck of a lot. We can resample the spline and add our movement input. Okay, this is great. I'm going to take a really quick restroom break, and then we'll keep working. I'm just throwing this comment here for those who joined the stream while I'm gone for the next minute or two. And I'll be right back, everyone. Okay, I am back. All right. So we can collapse this into a function. calculate current distance along spline. And this should be able to be pure. Okay. And this would probably be better to actually collapse, to actually make this in our actual motion spline class and follow principles of encapsulation properly. Okay, so now we'll just call this function. Whoops, what failed to compile? Ah. So this is one of the first things we're going to be doing every frame is getting our getting the closest spline point. And so we want to increment that distance to find our target transform value. So we're just, I think, always going to default to following the curve for now and incrementing it at a set incrementation step. And so I have the point settings map. So I can probably pull from that. Or no, not point settings, spline settings, because I have a resample step, and we're still going to use that now. So we're going to get motion spline settings, break this open, and add our resample step. And we're going to get our motion spline, get our spline path, get location at distance along spline. And global coordinate space. And this can be set to a target location. And there we go. There's one thing we're missing though. aside from me forgetting to plug in current spline distance to set it. We're not tracking our segment and updating it. And that's going to be very important to make sure that this all functions once we pass up the first spline segment point. So once we get our current spline distance, so once we get this value, so here's the issue. We could be approaching the end of our spline segment at the start of a frame, but we haven't incremented yet. So we could get stuck. Or if we add distance and we're at the end, so like that creates an issue. So we're going to get the closest distance on segment to world location. We're going to check if this is nearly equal. Okay, if this is less than or equal to, no, it should just be if this is less than our resample step. Where did I put that? Do we not access that? I thought I just grabbed that. Oh, here we go. So if this is true, then we are going to... Okay, so let's create an imaginary scenario here where our distance is 5 and our sample step is 10. So this shouldn't be... We need to do some extra math here, or this is going to be terribly wrong. We need to get... remaining distance on the segment. So let's create a new function. Get remaining I don't know what this is going to look at like. So let's prototype it out here. Let's get our motion spline ref, and from that get our map or our segment map. Find the segment. And can we... number of spline points minus 1. So this is our final distance. So let's do get segment distance, and we're going to input a segment key. I'm going to rename the input here to also be segment key. Make it more, or segment index. Okay, I did give that a good name, so I'll name this one segment index as well. Okay. So now we can call this function get what did I even name it? Get segment distance. But this should be a pure function. So now we can subtract the closest distance from the total distance, and this will give us the remaining distance. And we're going to check, is this remaining distance less than our resample step? And if that's true, then we need to sample the next spline segment. And this is a bit messy right now. We will clean this up. We'll definitely clean this up. So we're going to get the next spline point index. And we're not going to sample this yet, actually. Or yeah, we will. And what we're going to do here is we need to get an input for this that's taking this increment and finding that it along. So if we are, let's say our remaining distance is 7 and our increment is 10, we want to get this value at 3. So I think what we're going to do, so we have this increment, and what we have here is a value of 7. So we're going to subtract the remaining distance from this. So we're going to reason this in more than one place. So we need to make it a variable to keep this code clean. Let's promote this to a variable. Might make it local, might collapse this into a function, but for now, I'm going to name this remaining segment distance. And now we're going to check if the remaining segment distance is less than the incrementation distance. And if that is true, then how do we get that other value? We're going to subtract something from something else. My brain is apparently working a bit slow with this part of this here. So we need to subtract. What do we need to subtract? We have our remaining distance, and we have our resample step. We subtract our remaining distance from our sample step. Is that right, guys? So if our remaining distance is 7, and we subtract 7 from a sample step of 10, that gives us 3. Yeah, so that'll be right. That'll work. So we need a new function in our motion spline base. We need to I'm going to change this to get segment length. That's going to make more sense. And let's add a function named get location at segment distance. At distance along segments, and these are really verbose function names. I apologize. So we're going to input a distance and output a location. Okay, I want to look at, because we're tracking some values here. We need to make sure we're tracking everything. So we we have a remaining segment distance, but we want to set a current distance and a current location. And we get that by, how did we get that? Did I delete that? Okay, that's fine. That's fine. Where did I make that function at? Did I not make the function? Oh, here it is. Get location at distance along segment. And again, we need our segment index. We can find get location at distance along spline. This will be another pure function. So now what did I name that? I thought I named it get location at distance. Get location at distance along segment. There we go. So that accounts for our offset and keeps that all in line. Or should we just set the next point as the target? Because we're not considering if we want to stop at a point, and that's important. That is very important. And we're not going to be able to stop at a point if we're following a turn, if we're following a curve. So this resample is not going to be done, is only going to be done when we're trying to continuously follow a curve. And, maybe not. Maybe we can make this work for both cases. Let's see. It's going to be easier to modify than our old system, that's for sure. So much cleaner already. So we get the remaining segment distance. Okay, so this is the spot to do it. Okay, not necessarily, but what this is doing is this is just updating our distance along the spline and finding the next incrementation point. So this will all be fine as long as we track our current distance. So now we're going to either return this location or we're going to call that first function we made. Closest distance on segment to world, or no. What is it going to be? How do we get our main spline back? I feel like I already solved this and then accidentally deleted that section. Okay, we're getting a location at a distance along our segment, but we need to transpose from our segment back over to our normal spline. and get our distance along our main spline. And to do that, while accounting for having an intersection, and we could do this without the main spline, but then we couldn't to look forward past the current segment to predict stops and that kind of stuff, and we need to be able to do that. We need to be able to know this in relation to our main spline, not just our current segment that we're traveling on in case we have a very short segment for very tight curves and twists. And so what we should be able to do... that's it. So we know our current spline point index, or our previous spline point index. So we're going to get our spline path. And we're going to get distance at or along spline at spline point. So if we increment this, we're going to need to increment before we do this. Now we have our distance, and so we can add this. We're going to add, what we are going to add is... Okay, before I go in that direction, I'm going all over the place here, but we need to, increment our segment. So if this is less, then we need to increment our previous and next spline point indices. Didn't mean to drag that there. Okay, so I'm just really thinking about this. So the moment we cross that threshold and this is less, then we need to increment our spline segment index. We shouldn't increment our spline segment index yet, though, guys. We should, because we might not be on that segment yet. Darn. Oh, gosh, this is tricky. This is tricky. Okay. Okay. Dang. So right after we do this, if this is less than, then we need to we increment our segment because our target's going to go past it. Yep, so we do increment. My bad. Even if the current frame, it's not going to be there. So we could pass up a turn if we do that. And maybe this is the issue I ran into before, guys. And we need to be looking forward towards our turn for spins and for stops. And I guess the issue I'm running into that I could avoid is just that I'm trying to do a single spine resample and follow algorithm that just works. Like we give it a sample step. Okay, yeah, so this is what we're going to do. If our distance is less, then if that's true, we're not trying to carry over and preserve our sample step. We set this segment point to be the next target distance. So in that case, we're going to increment and set we're going to increment and reset our remaining segment distance. However, if this is false, we're going to use our current segment distance. And there we go. So this, wait, no. Okay, yeah, so this subtracts from that. I need to start commenting this or I'm going to confuse myself. Okay, guys. So this right here, we look at our main spline, look at our previous spline point, and we get the distance along the spline at that spline point, plus the current segment distance. So we're not going to reset remaining segment distance to 0. We're going to call this again. There might be a way to make this more efficient. We're doing a lot of like duplication of node groups in code here, so there's probably a algorithm or a way to look at this that simplifies it. So we increment. I mean, if this is true, we don't need to increment until the end of the frame, do we? And then start the next one. Okay, yeah. Think about this like a for loop. Think about this like a for loop. And this becomes the last thing we do. Very last thing. Like, so last that we put it off the sequence at the very beginning of everything. Or do we check we should increment and increment first before we do anything else? That's kind of what we're doing here. Maybe we do. Would that way be more beneficial? Would that way be more robust? Are you really going to travel that far within a single tick that it even matters? No, but I just would feel more comfortable. So maybe we do put it where I had it originally. We check what's our remaining stuff. What do we look like on this frame? Because we did move between frames. And kind of do a state check here. And if these are less, then we repeat. Yeah, we're going to put it here, guys. It's a more duplication of code, but I think it's going to work a bit better. End result might not even be noticeable, but oh well. So we're tracking our distance along the current segment, and that's all this is really doing. And now we reroute to combine these paths together. Into this here. And we use this to set our current spline distance. And now we have our spline distance for our current path, our main path, our main distance. So this should all work just fine. This code runs. We don't really have to duplicate it. And there we go. Perfect. That feels pretty clean, I must say. Okay. So now we have our current spline distance. And now we have our... we don't need this right now. We might not ever need to use this function. That's funny. Okay, that's fine. That's fine. I'd much rather be working from this now. So before we look at our distance, we have some conditions we need to check. We need to predict our ground movement stop location. And maybe pivot location as well. We'll just worry about stops for now. So, because we're looking ahead in case we need to stop, and we always want to do that. If in this code right here, where we're incrementing this, we could pass up a point that we're trying to stop at. So we want to, at the start of each frame, predict ahead and look at our stop location. If our next point, our next spline point index, if the data for that says that we should be stopping. So I reset this data. We're going to do that over here now. Well, we're really going to set our next spline point settings here where we do our incrementation. Okay. So now we can get our next spline point settings. So this isn't going to work if our stop is more than 1 point ahead. More than one segment ahead. We could have a separate array of stop points and check our stop location relative to each of those. When I made this struct, I was kind of thinking, well, we're always going to have enough room between the end of the previous segment and the start of the next stop. And I might just move forward with that assumption. Segments shouldn't be that close together. And if there's not room, then it should be, then the thing itself, the spline should be adjusted. So that's how I'm going to move forward. The assertion I'm going to move forward with. So, hey, if we should, so this is essentially going, if we should stop, then we need to check this. So there's values we need to get. I call this function in this mess of code over here somewhere. Here we go. Okay. We're just gonna, okay, yeah, we're gonna do that. And now I want to check to locate this against the location of our next spline point. In global space. If that is less than an error threshold of, let's say, 10. Now let's go to our motion spline point settings and add a float variable that is stop error radius. Now that's going to be tedious. No, I'll do it that way, give them more granular control. So if this is less than stop error radius, less than or equal to, we need to stop moving. So let's make a custom event. We'll name it stop. And this is going to set a can move boolean to false. Do a delay for the duration of the stop. And then set can move to true. What we're going to do is we're going to increment to the next spline point, because we should be at it by then. So I'm going to take all of this here and collapse it to a function. And I'm going to name it increment spline segment. Let's try not incrementing it, and let's see if we can get this function to handle that incrementation on its own. So if this is less than or equal to, then we call the stop event. And terminate. For the tick. If it's false, we continue. I'm going to collapse this to a function. Test stop is what I'll name the function. And I don't think we actually need to track our predicted stop location. That's the only place we're going to be using it. Okay, and I'm actually going to take this branch, cut it, get a return, add a Boolean output to the function. Why is this grayed out? I've never seen that before. That's really weird. Everything's grayed out. What the heck? I somehow started simulating. Okay, that's why. I'll name this should stop, and I'll make this a pure function since we can, and output that. Okay. I just want to keep that. It's a major piece of our logic flow. So I want to keep that there, where we can easily see it at this main level. We're only going to move if we can move. And we want to do all this every tick. So now we go as far as setting our current spline distance, and we are accounting for stopping at the next segment. So let's grab our other logic. We can plug this in here, and we have our current target location. So let's do a quick test, everyone. We're so close here. So close. Let's see if our add movement input works. We need to calculate our input vector. So we have our target vector and our input vector, our target location and our current location, I mean. That's what we need. Then let's I think we subtract current from target and normalize. In this case, we're going to normalize 2D. And this isn't going to apply any interpolation, which we may want to do. We probably will want to do. I'll go ahead and use that to set our input vector. Still very long execution chain, but much better organized, I think. Should be much easier to adjust different components as well. And now I just have to remember, how do I set this controller to actually be used? Think here. So let's set it to motion spline AI controller 2. And the only other thing is in our initial motion spline, or in my initial motion spline AI controller, I had to do some things. I needed to check if this was okay. Yeah, so let's just copy. Don't need all of this, but I'll delete what I don't need. So we're setting the character reference on possession, which is better than doing it on begin play, or might not find it on begin play yet. So we haven't set our motion spline reference, have we? So we can do that from our character once we know it's initialized with all the data. Don't need that in the current implementation, or that starts at 0. And all we want to do is just set can move to true. And this is all done in a sequence off of tick. just so that we keep trying until we know that that is initialized. So with that copied over, we should be good to try this out. What's a custom event here? That's interesting. Oh. I just need to get... Oh, because I already have begin play and I tried to paste begin play. Okay, there we go. Gonna move this up into view. Let's see how terribly this goes, everyone. Not off to a great start. Access none. Trying to read property. Get segment length. Huh. So we need to check if our motion spline base is ready before we continue with setting up the character, I think. So let's just create a variable. I'll name it ready. It's probably like a better programming pattern for this, but it's good enough. Ready should be false by default, but just in case. So we're not gonna gate to this. If that's valid, we'll set the values. And then in our controller, we're gonna say, is this ready? We already know our character is ready if we're this far. We're gonna reset. We're gonna go off a branch here. And now we're gonna do a sequence here, a sequence. Or we could just do an and like that. All right, let's do that. And I'm just hoping I was trying to access stuff a little bit too early. It's like it's out of sync. So access none. Trying to find a value. Huh. Okay. Well, guys, it is getting a little late. The stream's going on for 3 hours, and we're pretty close to getting this figured out. There's a few issues left to iron out, but I do believe that I'm going to end the stream here. So, yeah, I'm going to end the stream here, everyone. And if I have time between this week and next week, I'll try to get this finished up and working. If not, we'll finish it up and get it working in the next stream. So I'll see you all then. Thanks for tuning in. And yeah, I think that's it. Except actually in the stream and listen through something here to know when YouTube catches up, I think. So if I stop streaming,